Here is today's problem. The square root of 16x minus the square root of x equals 12. We want to find every value of x that makes this true. Before any algebra, we read the structure of the equation. It is a difference of two radicals equal to a constant. Inside the first radical, 16x means 16 multiplied by x. Inside the second radical, we have x all by itself. On the right-hand side we have the plain number 12. So the unknown is sitting under two different square roots. Equations like this respond well to squaring both sides. The plan is to isolate a radical, square, and repeat. Both radicals will disappear after 2 rounds of squaring. Squaring works best when a radical stands alone on one side. So our first job is to isolate the square root of 16x. Either radical could go first, and we pick the larger one. We add the square root of x to both sides of the equation. Adding the same thing to both sides keeps the equation true. On the left, minus root x and plus root x cancel each other. The left side keeps only the square root of 16x. The right side becomes 12 plus the square root of x. So now the square root of 16x equals 12 plus the square root of x. With one radical alone, we square both sides of the equation. If two quantities are equal, their squares are equal as well. On the left, squaring undoes the square root completely. The radical and the square are opposite operations, so the left side becomes exactly 16x, with no radical left. The right side is 12 plus root x, multiplied by itself. We expand that product one pair of terms at a time. First, 12 times 12 gives 144 as the opening term. The product has 12 times root x, and also root x times 12. Both cross terms are equal, which is why the middle doubles. Those two middle pieces add up to 24 times the square root of x. Finally, root x times root x brings back plain x. So the right side expands to 144 plus 20 for root x plus x. Our equation now reads 16x equals 144 plus 20 for root x plus x. Each term on the right came from one pair in the product. One radical is gone, but one radical is still in the middle. Before we square again, we gather the other terms together. We subtract x from both sides, and 16x minus x is 15x. Subtracting the same amount from both sides keeps the balance. We also subtract 144 from both sides to move it across. That leaves 15x minus 144 equals 24 times the square root of x. Now the only radical term is alone on the right-hand side. Every number in sight, 15, 144, and 24, divides evenly by 3. So we divide the entire equation by 3 to shrink the numbers. Dividing both sides by the same number is equally fair. 15x divided by 3 is 5x, and 144 divided by 3 is 48. On the right, 24 divided by 3 leaves 8 root x. So the equation becomes 5 by minus 48 equals 8 times root x. One radical remains, so we square both sides once more. This time the radical carries an 8 in front of it. The left side is the quantity 5x minus 48 squared. We expand it as 5 by minus 48 times 5 by minus 48. We multiply the two brackets term by term, in for products. First, 5x times 5 by gives 25x squared at the front. Then 5x times minus 48 appears twice in the expansion. Each copy is minus 240x, so together they make minus 480x. Finally, minus 48 times minus 48 gives positive 2304. A negative times a negative always turns out positive. For the 2304, we can use 48 times 50, which is 2400. 48 times 48 is 248 less, and 2400 minus 96 is 2304. That takes care of all four products in the expansion. So the left side is 25x squared, minus 480x, plus 2304. On the right, we square 8 times the square root of x. Squaring a product squares each factor inside it. 8 squared is 64, and the radical squared is plain x. So the whole right side collapses down to just 60 for x. Now we have to 5x squared, minus 480x, plus 2304 equals 60 for x. Every radical is gone, and a quadratic equation remains. We subtract 60 for x from both sides to set the equation to 0. The x terms combine as minus 480x minus 60 for x, which is minus 540 for x. So we get to 5x squared, minus 540 for x, plus 2304 equals 0. Now the whole problem is about solving this quadratic. This is a quadratic, so we bring in the quadratic formula. The formula works for any quadratic set equal to 0. Here, the number in front of x squared is exactly 25. The number on the plane x term is minus 544. And the constant at the end of the quadratic is 2304. The middle number carries its minus sign into the formula. The formula puts minus the middle number on top of the fraction. Minus of minus 544 is plus 544, so the top begins with 544. Next to it we add or subtract the square root of the discriminant. The discriminant is the expression that lives under that root. It equals the middle number squared, minus 4 times 25 times 2304. Those are exactly the three numbers we just identified. And the bottom of the fraction is 2 times 25, which is 50. So the entire answer comes down to computing that discriminant. So first we compute 544 squared, the middle number squared. We can split 544 into 500 plus 44 and square the sum. This split follows the same square of a sum pattern. 500 squared gives 250,000, a quarter of a million. Twice 500 times 44 is 1,000 times 44, which is 44,000. And 44 squared on its own comes out to 1936. Adding 250,000 and 44,000 brings us to 294,000. Then 294,000 plus 1936 lands exactly on 295,936. So 544 squared is 295,936, the first half of the discriminant. Now for the second half, 4 times 25 times 2,304. 4 times 25 is 100, so we just need 100 times 2,304. Multiplying by 100 attaches to zeros, giving 230,000 for 100. So the second half of the discriminant is 230,000 for 100. So the discriminant is 295,936 minus 230,000 for 100. We can do the subtraction into separate pieces. In the thousands, 295 minus 230 leaves 65. In the last three digits, 936 minus 400 leaves 536. So the discriminant comes out to exactly 65,536. In full, that is 65,536 sitting under the square root. It is positive, so the formula will hand us two values. Next we need the square root of 65,536 for the top line. The square root of 65,536 is exactly 256, a whole number. We can confirm it by squaring 256 as 250 plus 6. 250 squared is 62,500, and twice 250 times 6 is 3,000. Then 6 squared adds 36 more, for a total of 65,536. So the square root we need is a clean 256. The formula now reads x equals 544 plus or minus 256 over 50. So one value uses the plus, and the other uses the minus. We take the plus branch first and add 544 and 256. That addition gives 800 sitting on top of the 50. 800 divided by 50 is 16, since 50 times 16 is 800. So the plus branch gives our first candidate, x equals 16. Now the minus branch, which is 544 minus 256 on top. That subtraction gives 288, again sitting over 50. Dividing top and bottom by 2 turns it into 144 over 25. Nothing divides further, since 144 and 25 share no factor. 25 goes into 144 5 times, with 19 left over. And 19 over 25 is 0.76, so the decimal is 5.76. So the second candidate from the formula is x equals 5.76. The quadratic offers two candidates, 16 and 5.76. So the formula stage is finished, with two values in hand. We now test each candidate in the original equation. A candidate counts only if the original equation balances. We start with x equals 5.76 in both radicals. Under the first radical we need 16 times 5.76. 16 times 5 is 80, and 16 times 0.76 is 12.16. Adding those, the first radical holds 92.16 inside. The square root of 92.16 is 9.6, since 9.6 squared is 92.16. That is because 96 times 96 is 9,216, with the decimal shifted. The second radical holds 5.76, and its square root is 2.4. That fits because 2.4 times 2.4 is exactly 5.76. So the two radicals give 9.6 and 2.4 for this candidate. So the left side becomes 9.6 minus 2.4, which is 7.2. The right side is 12, and 7.2 does not equal 12. So 5.76 does not satisfy the original equation, and we discard it. That leaves x equals 16 as the only real solution. We check it by substituting 16 into the original equation. Under the first radical we need 16 times 16. 16 times 10 is 160, and 16 times 6 is 96. Adding 160 and 96 gives 256 under the first radical. The square root of 256 is 16, since 16 squared is 256. Under the second radical, we simply have 16 itself. The square root of 16 is 4, because 4 times 4 is 16, so the left side becomes 16 minus 4, which equals 12. The right side of the original equation is also 12. Both sides land on 12, so the equation balances perfectly. The value x equals 16 satisfies the equation exactly. Let us walk back through the whole solution once more. We started with root 16 x minus root x equals 12. We isolated the first radical by moving root x across. Squaring once produced 16x equals 144, plus 20 for root x, plus x. Tidying up and dividing by 3 gave 5 by minus 48 equals 8 root x. Squaring again led to the quadratic 25x squared minus 540 for x plus 2304. The quadratic formula returned to candidates 16 and 5.76. Testing showed 5.76 gives 7.2, while 16 gives exactly 12. Every step used only squaring, moving terms, and arithmetic. So the answer to today's problem is x equals 16. Thank you very much for watching to the end of the video. If it helped, a like and a subscribe support the channel. We will be back with another problem in the next video.